Hello and welcome back to the course on deep learning. Today we're talking about the neuron, which is the basic building block of artificial neural networks. So let's get started. Previously we saw an image which looked like this, and these are actual real-life neurons which have been smeared onto a glass and colored a little bit, and they are observed through a microscope. So this is what they look like. As you can see, quite an interesting structure, a body, and then lots of different tails, kind of branches coming out of them. And this is very interesting, but the question is, how can we recreate that in a machine? Because we really need to recreate it in a machine, since the whole purpose of deep learning is to mimic how the human brain works, in the hope that by doing so, we're going to create something amazing. We're going to create an amazing infrastructure for machines to be able to learn. And why do we hope for that? Well, because the human brain is just happens to be one of the most powerful learning tools on the planet, or like learning mechanisms on the planet. And we just hope that if we recreate that, we'll have something as awesome as that. So our challenge right now, our very first step to creating artificial neural networks, is to recreate a neuron. So how do we do that? Well, first of all, let's have a closer look at what it actually is. This image was first created by a Spanish neuroscientist, Santiago Ramón y Cajal, in 1899. And what he did was he dyed neurons in actual brain tissue and looked at them under a microscope. And while he was looking at them, he actually drew what he saw. And this is what he saw. He saw two neurons, or two large neurons over there at the top, which had all these branches coming out of them towards their top parts, and then each one of them had this rod or like thread coming out towards the bottom, very long one. And so that's what he saw. And now, technology has advanced quite a lot, and we have seen neurons much closer in more detail, and now we can actually draw what it looks like diagrammatically. So let's have a look at that. Here's a neuron. This is what it looks like. Very similar to what Santiago Ramón drew over here. And here in this neuron, what we can see is that it's got a body. Well, that's the main part of the neuron. And then it's got some branches at the top, which are called dendrites. And it's also got an axon, which is that long tail of the neuron. And so what are these dendrites for, and what's the axon for? Well, the key point to understand here is that neurons by themselves are pretty much useless. It's like an ant, right? An ant on its own can't do much. Like 5 ants together, maybe they can pick something up, but again, they can't build an anthill. They can't establish a colony. They can't work together as a huge organism. But at the same time, when you have lots and lots of ants, like you have a million ants, they can build a whole colony. They can build an anthill. Same thing with neurons. By itself, it's not that strong, but when you have lots of neurons together, they work together to do magic. And how do they work together? That's the question. Well, that's what the dendrites and the axon are for. So the dendrites are kind of like the receivers of the signal for the neuron, and the axon is the transmitter of the signal for the neuron. And here's an image of how it all works conceptually. So at the top, you've got a neuron, and you can see that its dendrites are connected to axons of other neurons that are like even further away above it. And then the signal from this neuron travels down its axon and connects or passes on to the dendrites of the next neuron. And that's how they're connected. And in that small image over there, you can see that the axon doesn't actually touch the dendrite. A lot of machine learning, or like a few machine learning scientists are very adamant about the fact that it doesn't touch. It doesn't touch. It has been proven that there is no physical connection there. But the point that we're interested in is that connection between them, that the whole concept of the signal being passed, that's called a synapse. You can see over there in that little image, that's figure bracket is a synapse, and that's the term we're going to be using. So instead of calling our artificial neurons, the lines that we're going to have, or the connectors for artificial neurons, we're not going to be calling them axons or dendrites, because then the question is, whose connection is this? Is it that neurons, or is it this neurons? We're just going to call them synapses. And that's kind of just answers all questions right away. That's just basically where the signal is passed. Doesn't matter who that element belongs to. That's just a representation of the signal being passed, and we'll see that just now. So basically, that's how a neuron works. And so let's move on to how we're going to represent neurons, or how we're going to create neurons in machines. So we're moving away, now we're moving away from neuroscience and moving into technology. And here we go. So here's our neuron, also sometimes called the node. The neuron gets some input signals and it has an output signal. So dendrites and axons, remember, but again, we're going to call these synapses. Then these input signals, we're going to represent them with other neurons as well. So in this specific case, you can see that this neuron, this green neuron, is getting signals from yellow neurons. And in this course, we're going to try and stick to a certain color coding regime where yellow means an input layer. So basically, all of the neurons that are on the outer layer or in the first front of where the signal is coming in. And by signal, it might be like a bit of an overkill to call this a signal. It's just basically input values. So you know how even like in a simple linear regression, you have input values and then you have a predicted value. Same thing here. So you have input values, and there they are, the yellow ones. And then on the right, you'll see just now, it'll be red. It'll be the output value. The thing that I wanted to point out here is that in this specific example, we're looking at a neuron which is getting its signals from the input layer neurons. So they're also neurons, but they're their input layer neurons. Sometimes you'll have neurons which get their signal from other hidden layer neurons, so from other green neurons, and the concept is going to be exactly the same. And just in this case, for simplicity's sake, we're portraying this example. And in terms of the input layer, the way to think about it is, in the analogy of the human brain, the input layer is your senses, right? So whatever you can see, hear, feel, touch, or smell. And of course, it's like there's a lot of things you can see. There's a lot of information coming in, but that's what your brain is limited to. It's pretty much it's pretty much lives in a box made out of bones, and it's a mind-blowing concept to think about, that your brain is just locked in a black box, and the only thing, like, it can't see, it can't hear. The only thing it's getting is electrical impulses coming from these organs that you have, which are called your ears, nose, eyes, your sense of touch, and whatever, and your taste, right? So it's just getting signals, but it basically lives in this dark black box, and it's making sense of the world through your senses. It's phenomenal. And so you have these inputs that are coming in. In the terms of human brain, those are your 5 senses, and in terms of machine learning or deep learning, that is basically your input values, so your independent variables, and we'll get that to in a second. So your input values, the signal is passed through synapses to your neuron, and then your neuron has an output value that it passes further on down the chain. In this specific case, in terms of color coding, again, yellow means input layer. So we're kind of simplifying everything here. We're saying we're only going to have like the input layer, then we're going to have one hidden layer with the green, which is the hidden layer, and then we're going to have the output layer right away. So just so that we can get used to these colors for now. So there we go. That's the basic structure. So now let's look in a bit more detail at these different elements that we have. So we've got the input layer. And what do we have here? Well, we have these inputs, which are in fact independent variables. So independent variable 1, independent variable 2, independent variable m. And the important thing to remember here is that these independent variables are all for one single observation. So think of it as just one row in your database, one observation. You just take all of the independent variables, maybe it's the age of the person, the amount of money in the bank account, and then how do they drive or walk to work? What method of transportation do they use? So, but that's all descriptors of one specific person that you are either you're training your model on or you're performing some prediction on. The other thing you need to know about these variables is that you need to standardize them. So you need to either standardize them, which means make sure that they have a mean of 0 and a variance of 1, or you can also sometimes, and Hadlan will point out these situations in a bit more detail, perhaps in the practical tutorials you might come across these. Sometimes you might want to not standardize, you might want to normalize them, meaning that instead of making sure the mean is 0 and variance is 1, you just take you subtract the minimum value and then you divide by the maximum minus the minimum, so by the range of your values, and therefore you get values between 0 and 1. And it depends on the scenario. You might want to do one or the other, but basically you want all of these variables to be quite similar in about the same range of values. And why is that? Well, all of these values are going to go into a neural network where, as we'll see just now, they'll be added up and multiplied by weights, added up, and so on. And just going to be easier for the neural network to process them if they're all about the same. And in fact, that's just how it is going to be able to work properly. And if you want to read more about standardization, normalization, and other things that you can do with your input variables, a good additional reading paper is called Efficient Backprop by Jan LeCun, 1998. The link's over there. So Jan LeCun, we're actually going to talk more about this phenomenal person in the space of deep learning in the part of the course where we're talking about convolutional neural networks, and you'll see that this is definitely a person who knows what he's talking about. He's a close friend of Geoffrey Hinton, who we've already seen, who we've already mentioned. So in this paper, you'll learn more about standardization and normalization, but also you can pick up lots of other different tips and tricks, and it'll be a good source for additional reading as you go through this course. So yeah, check it out if you're interested in some additional reading. There we go. So that's what we need to do with the variables. And here we've got the output value. So what can our output value be? Well, we've got a couple of options. Output value can be continuous, like for instance, price. It can be binary, for instance, a person will exit or will stay, or it can be a categorical variable. And if it's a categorical variable, the important thing to remember here is that in that case, your output value won't be just one, it'll be several output values, because these will be your dummy variables, which will be representing your categories. And that's just how it works. And just important to remember that in that case, that's how you're going to be getting your categories out of the artificial neural network. But let's go back to a simple case of one output value. And now let's, one more point, or kind of like the point that we've already made. I just wanted to reiterate this point. On the left, you've got a single observation. So one row from your data set, and on the right you have a single observation as well. And that is the same observation. So important to remember that, like, whatever inputs you're putting in, that's for one row, and then the output you get, that is for that same exact row. Or if you're training your neural network, then you're putting the inputs in for that one row, you're putting the output in for that one row. So like, if you want to simplify the complexity, think of it as like a simple linear regression or a multivariate linear regression. So you're putting in your values, you have your output. There's no question about it when we're talking about things like regression, because we're so used to it. Same thing here. It's nothing too complex. We're just putting in values, we're getting output, but just remember that every time it's one row you're dealing with, so you don't get confused and start putting in thinking that these are different rows that you're putting into your artificial neural network or something. This is all just values in that one row. So different observation, different characteristics or attributes relating to that one observation every single time. Okay, so next thing that we want to talk about here is the synapses. Here we've got synapses, and they all actually get assigned weights. Weights, we're going to talk more about weights further down, but in short, weights are crucial to artificial neural networks functioning, because weights are how neural networks learn. By adjusting the weights, the neural network decides in every single case what signal is important, what signal is not important to a certain neuron, what signal gets passed along and what signal doesn't get passed along, or to what strength, to what extent signals get passed along. So weights are crucial. They are the things that get adjusted through the process of learning. Like when you're training an artificial neural network, you're basically adjusting all of the weights in all of the synapses across this whole neural network. And that's where gradient descent and backpropagation come into play. And those are concepts that we'll also discuss. So basically, those are the weights. That's all we need to know for now. And here we've got the neuron. So signals go into the neuron. And what happens in the neuron? So this is the interesting part. Like, we're talking about the neuron today. What happens inside the neuron? So a few things happen. First thing, and the first step, is that all of these values that it's getting get added up. So it takes the the weighted sum of all of the input values that it's getting. Very simple, right? It's very, very straightforward. Just add up, multiply by the weight, add them up. And then it applies an activation function. Now we're going to talk more about activation functions further down, but it's basically a function that is assigned to this neuron or to this whole layer. And it is applied to this weighted sum. And then from that, the neuron understands if it needs to pass on a signal. If it, that's the signal that it passes on, that the function applied to the weighted sum. But basically, depending on that function, the neuron will either pass on a signal or it won't pass the signal on. And that's exactly what happened here in step 3. The neuron passes on that signal to the next neuron down the line. And that's what we're going to talk about in the next tutorial, because it is quite an important topic. We want to delve deeper into the activation function. But hopefully for now, everything should be pretty clear. How, you've got input values, you've got weights, you've got the synapses, you've got something, happens in the neuron, you've got the weighted sum, and then an activation function applied, and then that is passed down the line. And that is just repeated throughout the whole neural network, on and on and on and on. Thousands, hundreds of thousands of times, depending on how many neurons you have, how many synapses you have in your neural network. So there we go. Hope you enjoyed today's tutorial. Can't wait to see you next time. And until then, enjoy deep learning.